Alright, in the last lecture we have talked about how to traverse through a circle single linked list, and we have implemented it in practice. Now in this video we are going to talk about how to search a given node inside circle single linked list. Now here the algorithm is same as with a simple single linked list. Now when we are discussing searching in single linked list, we have said that we are doing linear search. So this means that we are starting from first node and checking value with the value that we are looking for. If it is the value, we are stopping over here. If it is not, we are continuing to the next node over here. Now here an important moment is this circle single linked list might cause infinite loop. So when we are reaching the last element and we have not found the value that we are looking for, in this case it might come to the first element and it might loop through the circle single linked list infinitely. Now to prevent these cases, as we mentioned before, we are using size property. So if we keep the size of circle single linked list, we can easily identify how many elements we have in our circle single linked list. So this will prevent infinite loop in our case. Now here, let's say if we want to search for a value of 3, then in this case we are going to start from the first node. So we will check that if this is the value that we are looking for or not. So in the first node we have a value of 1. So this means that we need to continue to the next node. So we are going to traverse to the next node, and one more time we are checking that if this node's value is equal to 3 or not. Now you see that it's equal to 2. So this means that we are going to continue to the next node. Now when we reach the node 3, we see that node 3's value is 3. So this means that this is the value that we are looking for. So we will stop over here printing out saying that the value is found at the index of 2, because first node's index is 0, second node's index is 1, and the third node's index is 2. So we have found our value at the index of 2. Now let's see how the algorithm of this searching looks like in case of circle single linked. Now here algorithm starts with node values. So this is the parameter that our method will take. So we are looking for this node value. Now the first thing, as always, we are going to check that if this circle single linked list exists or not. So if head value is equal to null, we are terminating our algorithm and printing out message saying that the linked list is not exist. Otherwise, we are continuing to the current node's value. So we are checking that if the current node's value is equal to node value that we are looking for, in this case, we are printing out message saying that we have found this node at this location. Otherwise, we are continuing until we reach the size of circle single linked list. So if we reach the last element and we have not found the value that we are looking for, in this case it means that this node value is not exist in our circle single linked list. Now this is how searching works in case of circle single linked list. Now based on this algorithm, we are going to create our method in Java. So let's head over to Java and create our method over there. Now here we are going to create our search method after the traversal method that we created in our previous lecture. Now here our search method will return Boolean value. So if the node value that we are looking for exists in our circle single linked list, in this case we are going to return true. Otherwise we are going to return false. So that's why I'm going to declare our method like this: public Boolean will be search node method. So in this case it will take as a parameter node value. So as we said, we are creating integer type of linked list. So that's why in this case I'm going to put parameter as an integer. Then, as we said before, the first thing that we are going to do, we are going to check the head value. So as you see, this search method is kind of similar to the traversal method over here, but the only difference is inside this loop we are going to put another if condition over here. So that's why it's going to be like this: if head is not equal to null, then in this case we are going to start loop through this circle single linked list. So in this case, what we are going to do, I'm going to create node, temp node, and we'll set the head value to it because we are starting from head value. Then we are going to loop through the circle single linked list until we reach the size of circle single linked list. So I will start from 0 and it will continue until the size, and it will be increased by 1. Then we are going to put if condition like this: if temp node's value is equal to the node value that we have set in our parameter, then in this case we are going to print out to the console saying that not found at the location of I, and then we are going to return true. Otherwise we are going to continue to the next node until we have finished visiting all nodes in circle single linked list. So I'm going to put if condition like this: if temp node dot value equals node value, then in this case we are going to print to the console saying that found node at location. So I'm going to concatenate it with I, because in this case I will be the index of this node over here. Then we are going to return true, because in this case we don't need to continue to the next node because we have found our node over here. Otherwise, outside this if condition, I'm going to put temp node to temp node.next, because we are continuing to the next node in this case. Now, if we have finished our loop and we have not found the value that we are looking for, in this case it means that our value is not exist in this list. So we can put a message over here saying that the node is not found, but I'm not going to put it over here. I'm going to put it outside this if condition, because if the linked list does not exist, it means that the node that we are looking for is not exist in this linked list. So I'm going to put only one message over here. So our method also will return false in this case. So I'm going to put a message over here saying that node not found. Then after this message, I'm going to return false. So with this, we have completed our method. Basically, what we are doing over here is we are visiting all nodes of circle single linked list until we reach the size of this circle single linked list. So with this, we are preventing infinite loop, and in each step we are checking that if the current node's value is equal to node value that we are looking for or not. So if it is, then it means that we have found the node at this location. Otherwise, we will continue to the next node. So if we have not found the node that we are looking for after visiting all nodes, we will print out to the console saying that node not found. Now let's see how this is working in practice. So what I'm going to do after traversal, I'm going to look for example, search node for the value of 5. So we know that 5 exists in our circle single linked list, so it should find this 5 over here. You see that first it's printing out our circle single linked list. Now you see that 5 is located at the index of 2. So our message says that not found at the location of 2 over here. So 4 is located at the index of 0, 6 is located at the index of 1, and 5 is located at the index of 2. So our method works the way that we want. Now if I put, for example, over here 10 and search for 10, 10 is not exist in our circle single linked list. So in this case, it should print out to the console saying that node not found. So as you see, it prints out to the console saying that node not found. So our method works the way that we want. So we have implemented search method successfully. Now let's see what's the time and space complexity for this method over here. Now as always, we are going to start from the first line of this method. So in this case, we have if condition in which we are checking head. So this means that this if condition will take O1 time complexity. Then we have created temporal node and set the head value to it. So this is also taking O1 time complexity. Then we have loop condition over here in which we are looping until we reach the size of circle single linked list. Now this means that in the worst case, if the node is located at the end of circle single linked list, we have to visit all nodes of circle single linked list. So this means that if the size is n, so the time complexity will be On. Now inside this loop, we have if condition over here in which we are checking that if the current node's value is equal to node value. If it is, we are printing out to the console message and we are returning true. Now this if condition over here will take O1 time complexity, because here time consuming operation is not performed. This is just a simple if condition, and then we are printing out message to the console. Now then we have continued to the next line of code. So in the next line of code, we are setting temp node's next value to the temp node. So this is just simple assignment statement. So we know that assignment statement takes O1 time complexity. Now then at the end, we are printing out to the message saying that node not found, and we are returning false. So these two lines of code also will take O1 time complexity, because we know that printing out message to the console takes O1 time complexity and returning false also takes O1 time complexity. Now if you combine all these complexities over here, we will get On time complexity, because in this loop we have On time complexity over here. So this is dominant term, so this means that O1s are non-dominant terms. So these O1s will be eliminated from the complexity. We will get On time complexity. Now the space complexity is O1, because in this case an additional memory is not required to perform this searching method over here. So that's why space complexity is O1. Now with this, we have completed our search method. So hopefully everything is clear about searching for a value in circle single linked list. Now see you in the next lecture.